Question 1. In a modern context of electrical safety and HVAC work, BL is tasked with replacing a faulty contactor in a rooftop unit located in a commercial building. The main disconnect is visible from his work area but is partially blocked by ductwork. He believes he can simply open the disconnect and proceed, but a coworker suggests performing full lockout-out before beginning. Which action aligns best with safety standards? A. Proceed after turning off the disconnect since it's visible. B. Proceed only if the equipment has secondary power verification. C. Perform full lockout-out procedure before starting work. D. Remove the disconnect handle and keep it nearby. Answer. Correct answer. C. Explanation. OSHA and NFPA 7 require full lockout-out for any energized HVAC work where hazards exist even if the disconnect is in sight. Visibility does not guarantee safety. Unexpected re-energization is possible. A and B rely on partial measures which don't meet standards. D is unsafe and violates lockout protocols. Proper LOTO includes de-energizing, locking, tagging, and verifying zero energy state before work. Question 2. From the perspective of optimizing motor control, technician Siren notices a supply fan VFD in an air handling unit frequently trips on overcurrent during startup. The motor and wiring are rated properly and the load is within limits. What is the most likely corrective adjustment? A. Reduce the acceleration time in the VFD programming. B. Increase the acceleration time in the VFD programming. C. Lower the carrier frequency of the VFD output. D. Install a larger motor to handle and rush current. Answer. Correct answer. B. Explanation. Excessive current trips on startup often occur due to rapid acceleration. Increasing ramp time reduces inrush. Easing the motor into load. 8. Worsens current spikes. C. May reduce ME but doesn't fix overcurrent. D. Is unnecessary if motor sizing is correct. Proper VFD commissioning per manufacturer guidance. E. G. NEMA MG ensures settings match load characteristics. Question 3. When evaluating start capacitor failure in a single-phase compressor, Alex observes that the motor struggles to start, produces a humming sound, and trips the thermal protector. Voltage and connections are normal. Which diagnosis is most accurate? A. Run capacitor open, requiring replacement. B. Start capacitor failed, open or shorted. C. Contactor coil voltage too low. D. Breaker undersized for load. Answer. Correct answer. B. Explanation. Start capacitor failure causes high starting torque issues. Humming, slow rotation, thermal trips. 8. Would affect running performance, not primarily starting. C. Would prevent contactor from pulling in. D. Would trip during operation but not cause slow start symptom. Testing with capacitance meter confirms the fault. The per ESA best practice match off and voltage rating in replacement. Question 4. Taking into account complex HVACR control systems, which steps should a technician prioritize when troubleshooting? A heat pump defrost circuit using a ladder diagram. A. Trace the low voltage control circuit from thermostat to defrost board. B. Test all high voltage components for continuity. C. Measure compressor winding resistance first. D. Replace the defrost control board before testing. Answer. Correct answer. A. Explanation. Ladder diagrams show control logic flow. Tracing the low voltage path ensures sequential verification of inputs and outputs. B. Is premature unless control voltage checks fail. C. Is unrelated to initial control circuit diagnosis. D. Risks unnecessary part replacement. Following a systematic approach per ANSI standards prevents misdiagnosis. Question 5. Given the circumstances of an HVAC unit repeatedly tripping its circuit breaker during heat mode, Jamal confirms there are no short circuits, loads match design, and breaker is correctly rated. What is the most probable cause? A. Breaker experiencing nuisance trips due to ambient temperature derating. B. Breaker defective and must be replaced without further testing. C. Transformer winding short. D. Improper neutral ground bonding in control circuit. Answer. Correct answer. A. Explanation. NEC 210.20 and breaker specs account for ambient derating. Excessive heat near the panel can cause nuisance trips under normal load. B is possible but should be verified before replacement. C would blow fuses or cause secondary issues. D affects safety but not breaker tripping under load. Relocating breaker or improving ventilation resolves thermal derating. Question 6. Through the lens of efficiency, a SE motor in a packaged unit is running hot despite normal current draw. Windings test normal. Which factor is most likely causing the overheating? A. Insufficient airflow over motor housing. B. Incorrect capacitor rating slightly above spec. C. Supply voltage slightly above nameplate rating. D. Dirty power from harmonics in supply. Answer. Correct answer. A. Explanation. PSC motors rely on airflow for cooling. Restricted ducting or blocked vents can cause thermal rise without overcurrent. B. Can affect torque but not cause the symptom of close to spec. C. Small overvoltage may increase heat, but airflow issues are more probable. D. Affects electronics more than induction motors. Follow NEMA MG ventilation guidance. Question 7. As evidenced by troubleshooting, technician Prayer finds erratic thermostat signals in a split system causing random cycling. Which cause is most consistent with this symptom? A. Low voltage short to ground on thermostat cable. B. Transformer undersized for total control load. C. Cross thermostat wires causing backfeeding. D. Incorrect breaker size in the control circuit. Answer. Correct answer. C. Explanation. Crossed wires A, G, R and Y can backfeed signals causing unpredictable operation. May would likely blow a control fuse immediately. B causes voltage sag under load but not random cycling. D is irrelevant for 24th control circuits. Correct diagnosis involves continuity checks and referencing wiring diagrams per manufacturer's control schematics. Question 8. When analyzing a control transformer overheating issue in a rooftop unit, all loads appear normal and voltages within limits. Which is the most likely underlying cause? A. Transformer secondary winding short. B. Continuous operation near maximum VO rating. C. Incorrect grounding on secondary side. D. Open primary winding connection. Answer. Correct answer. B. Explanation. Continuous loading near max VAR causes thermal buildup even within voltage limits. A. Would cause rapid overheating and likely trip protection. C. Is a safety concern but not a direct heating cause. D. Would prevent operation entirely. Sizing per NEC 450 ensures adequate capacity with margin for inrush and ambient temperature. Question 9. In light of recent developments in diagnostic tools, Jorge uses a thermal imager and finds a hot spot at a compressor terminal connection. The compressor runs normally, otherwise weighs the most appropriate action. A. Continue operating until the unit shows symptoms. B. Tighten the terminal connection after isolating power. C. Replace the compressor immediately. D. Reduce system charge to lower load. Answer. Correct answer. B. Explanation. Loose connections cause resistance heating visible as hot spots on thermal imaging per NFPA 7 tip. Tightening with LOTO applied prevents further damage. A. Risks terminal burnout. C. Is unnecessary if compressor is functional. D. Does not address electrical heating sources. Periodic torque checks align with preventive maintenance standards. Question 10. The underlying principle of a contactor's operation is based on electromagnetic force pulling the armature closed. If the contactor coil receives rated voltage but fails to pull in, which cause is most probable? A. Mechanical binding and armature linkage. B. Coil resistance too high. C. Supply frequency too high. D. Load current exceeding contact rating. Answer. Correct answer. A. Explanation. If voltage is correct, failure to pull in suggests mechanical obstruction or dirt preventing movement. B. Affects coil performance but would reduce magnetic field. However, rated voltage suggests current is present. C. Frequency variations within HVACR range are negligible. D. Affects contact heating after engagement, not coil actuation. Cleaning and inspection resolve binding. Question 11. Taking into account a service call for a walk-in freezer, technician Omar finds that the evaporator fan motors are not running, but the compressor is operating normally. Control voltage to the fan circuit is absent. What should Omar do first? A. Replace the evaporator fan motors. B. Inspect the defrost termination switch for continuity. C. Replace the defrost timer immediately. D. Check the breaker feeding the compressor circuit. Answer. Correct answer. B. Explanation. When evaporator fans stop during defrost and fail to restart the defrost termination switches, a likely cause, it signals fans to resume after coil temperature drops. A. Risks replacing functional motors. C. May be warranted only if timer faults are verified. D. Is irrelevant since the compressor circuit is working. Following systematic troubleshooting per OEM wiring diagrams avoids unnecessary parts replacement. Question 12. In contrast to common electrical faults, technician Hannah encounters a contactor that closes intermittently despite stable coil voltage. What is the most probable cause? A. Coil insulation breakdown under heat. B. Pitted or corroded contact surfaces. C. Excessive mechanical spring tension. D. Loose wiring on the load side. Answer. Correct answer. C. Explanation. Excessive spring tension can prevent consistent closure even with proper coil voltage, causing intermittent operation. A. Would cause coil overheating and possible complete failure, not sporadic actuation. B. Affects conductivity but doesn't prevent mechanical closure. D. Impacts load delivery, not contactor movement. Proper mechanical inspection per ECHL guidelines is necessary. Question 13. From a practical standpoint, when installing a new rooftop HVACR unit, Michael must route low-voltage thermostat wiring alongside high-voltage conductors in a shared conduit. What is the net-compliant approach? A. Use any available spare conduit space as long as conductors are insulated. B. Only run low voltage and high voltage together if conductors are rated for the highest voltage present. C. Run low voltage in a separate conduit from high voltage circuits. D. Twist low voltage conductors to minimize interference. Answer. Correct answer. B. Explanation. NEC 300.3c allows mixed voltages in the same raceway only if all conductors are insulated for the highest present voltage. A. Violates insulation rules. C. Is safe but not strictly required if insulation meets the rule. D. May reduce noise but doesn't ensure code compliance. Insulation rating verification is critical for mixed voltage runs. Question 14. Based on the information gathered during inspection, technician Lewis finds a shaded pole motor in a condenser fan running slowly with no unusual sounds or heat. Voltage and load are normal. What is the likely cause? A. Partially shorted stator winding. B. Dry bearings increasing friction. C. Improperly installed fan blade orientation. D. Weak magnetic shading coil. Answer. Correct answer. D. Explanation. A weak shading coil reduces starting torque and operating speed without causing overheating or noise. A. Would cause overheating and possible tripping. B. Creates noise and heat due to drag. C. Can alter airflow but not motor speed. Shaded pole motors are sensitive to shading coil condition. Replacement is often the remedy. Question 15. When presented with a compressor not starting, technician Naomi measures iron voltage at the contactor output but finds 0 volts at the compressor terminals. What is the most likely cause? A. Faulty run capacitor. B. Open thermal overload in compressor. C. High pressure switch open. D. Shorted compressor winding. Answer. Correct answer. B. Explanation. The open thermal overload interrupts voltage at compressor terminals while voltage is still present at contactor output. A. Affects starting torque, but voltage would still be at terminals. C. Would interrupt control voltage, not line voltage at compressor. D. Would show low resistance, not 0 voltage. Per standard diagnostics, allow cooling and check overload continuity. Question 16. The most significant aspect of staging electric strip heaters is preventing excessive inrush and avoiding voltage drop. How is this typically achieved? A. Using a single contactor for all heater banks. B. Staggering heater activation via sequencing relays. C. Running heaters at reduced voltage. D. Connecting all heaters directly to the breaker panel. Answer. Correct answer. B. Explanation. Sequencing relays stagger heater engagement to prevent large inrush currents per manufacturer and NEC guidelines. A. Causes simultaneous high load. C. Is inefficient and can damage heaters. D. Lacks control and staging. Proper sequencing protects circuits and maintains voltage stability under load. Question 17. Throughout the course of servicing, a split system technician Carla finds that the outdoor unit's control circuit operates normally, but the compressor fails to start. Power circuit voltage at compressor terminals is 0. What does this indicate? A. Open contactor in the power circuit. B. Failed start relay. C. Blown low voltage fuse in the control circuit. D. Defective thermostat. Answer. Correct answer. A. Explanation. 0 volts at compressor terminals despite normal control operation points to an open in the power circuit. Often the contactor contacts themselves. B. Affects start winding engagement, not complete voltage loss. C. Would disable the control circuit, not just compressor power. D. Would prevent control signal altogether. Per troubleshooting flowcharts, isolate and test contactor continuity. Question 18. By comparing different termination methods, which practice ensures the most reliable high-voltage HVACR connection in a vibration-prone environment? A. Using wire nuts rated for high vibration use. B. Crimping with insulated terminals and applying heat shrink tubing. C. Soldering connections and wrapping with electrical tape. D. Tying conductors with cable ties to reduce strain. Answer. Correct answer. B. Explanation. Crimped insulated terminals with heat shrink provide secure, vibration-resistant connections per ULAB. A. Is less secure over time. C. Soldered joints can crack under vibration. D. Reduces strain, but doesn't improve connection integrity. Following manufacturer torque and crimped specifications ensures reliability in high vibration HVACR settings. Question 19. Demonstrated by an inspection, a condenser fan motor shows correct supply voltage but will not run. Capacitors within spec. Resistance readings between all leads are balanced, but motor still doesn't start when powered directly. What's the likely fault? A. Open winding in motor. B. Internal centrifugal switch stuck open. C. Seized rotor bearing. D. Thermal protector stuck open. Answer. Correct answer. C. Explanation. A seized bearing prevents rotation even with correct electrical readings indicating mechanical failure. A. Would show open resistance. B. Is common in split-phase motors, but less likely if resistances are normal. D. Would block voltage to windings. Mechanical inspection complements electrical testing for accurate fault isolation. Question 20. The core principles of isolating a short circuit in a rooftop unit involve minimizing system downtime and preventing component damage. If the 24th control fuse blows immediately when thermostat calls for cooling, what is the next logical step? A. Replace the fuse with a high-rated one. B. Disconnect all control loads and reconnect one at a time. C. Replace the thermostat first. D. Replace the contactor coil immediately. Answer. Correct answer. B. Explanation. Sequential reconnection isolates the shorted component efficiently. A. Is dangerous and violates neck protection principles. C. Is only necessary if thermostat tests faulty. D. Should be confirmed by isolation testing. This method aligns with systematic troubleshooting to protect circuits and pinpoint faults quickly. Question 21. When considering a rooftop unit that experiences repeated low-voltage transformer failures, technician Andre finds that the 24th wiring runs alongside a high-voltage conduit for 60 feet before entering the air handler. Which action is most likely to prevent further transformer damage? A. Increase transformer VO rating significantly. B. Install a dedicated low-voltage conduit away from high-voltage runs. C. Install a larger primary fuse on the transformer. D. Add a secondary surge suppressor only. Answer. Correct answer. B. Explanation. Long parallel runs with high voltage conductors can induce voltage into low voltage wiring, stressing transformer insulation. NEC requires separation unless all conductors are rated for the highest voltage. A. Risks overheating without addressing interference. C. Defeats overcurrent protection. D. Helps against spikes but not induced coupling. Physical separation eliminates any risk and protects transformer life. Question 22. By evaluating a rooftop unit that trips its breaker randomly, technician Lena measures steady running current well below breaker rating. However, thermal imaging shows one-phase conductor abnormally hot near a luck connection. What is the most appropriate corrective action? A. Replace the breaker immediately. B. Tighten and retorque the lug connection to manufacturer spec. C. Replace the conductor with larger gauge wire. D. Install an oversized breaker to handle heat rise. Answer. Correct answer. B. Explanation. Overheating a lug with normal load indicates high resistance due to a loose connection. Retorquing per ULAB ensures safe conductivity. A is premature. Breaker isn't at fault. C is unnecessary unless conductor is undersized. D is unsafe and violates NEC 240.4. Torque verification is part of preventive maintenance to avoid fire hazards. Question 23. A key distinction between primary and secondary faults is the pattern of symptoms. In a split system, the control transformer repeatedly blows its primary fuse only during heating mode, which cause is most likely A. Shorted secondary wiring to reversing valve solenoid. B. Shorted heat sequencer coil on secondary side. C. Ground fault on high voltage feeder heat strips. D. Incorrect transformer VA rating. Answer. Correct answer. C. Explanation. Blown primary fuses during heating often point to high voltage faults such as ground faults in heater circuits, which backfeed through transformer primary via shared circuits. A and B would blow the secondary fuse. D causes overheating, not immediate fuse trips. NEC 450 and manufacturer schematics help identify cross-circuit connections that can create backfeed paths. Question 24. When analyzing a compressor startup failure, technician Brian finds proper voltage at terminals, correct capacitor value, and windings within normal resistance range. The compressor hums but fails to rotate. What is the most probable cause? A. Mechanical locking compressor. B. Contactor coil shorted to ground. C. Thermostat short cycling. D. Excessive refrigerant overcharge. Answer. Correct answer. A. Explanation. Proper electrical readings with no rotation indicate mechanical seizure in the compressor. B. Would prevent contactor engagement entirely. C. Would cycle power but allow it starting between calls. D. Increases load but wouldn't prevent rotation if torque is adequate. Manufacturer's lock rotor amperage check confirms diagnosis before recommending replacement. Question 25. In the absence of visual defects, technician Zoe measures a run capacitor 15% below its rated microfarads on a blower motor circuit. The motor runs but draws slightly above nameplate amps. What is the correct action? A. Replace the capacitor immediately. B. Continue operation and monitor motor temperature. C. Reduce fan speed to lower load. D. Increase capacitor size by 20% to compensate. Answer. Correct answer. A. Explanation. NEMA-MG recommends replacing capacitors more than 10% out of spec to prevent overheating and efficiency loss. B. Risks long-term motor damage. C. Treats symptoms but not cause. D. Oversizing can cause premature motor failure. Capacitor testing is a preventive measure. Replace with correct rating and voltage tolerance. Question 26. From multiple perspectives, technician David installs a new condensing unit and plans to place the disconnect switch 10 feet away, behind a wall. How does this align with NEC requirements? A. Acceptable if clearly labeled. B. Acceptable if within sight and readily accessible. C. Not acceptable. Must be within sight and without obstructions. D. Acceptable only if lockable breaker is used. Answer. Correct answer. C. Explanation. NEC 440.14 requires HVAC disconnects to be within sight and accessible without obstructions. 10 feet behind wall does not meet. Within sight definition, A and D don't meet physical visibility accessibility rules. B is correct only if actually within sight. Safety and emergency shutdown access are primary compliance concerns. Question 27. Contrary to popular belief, PPE requirements for HVAC or electrical work are not solely dependent on system voltage, which factor is equally critical in determining PPE category: A. Ambient temperature, B. Available fault current and arc flash incident energy, C. Type of compressor used in the system, D. Age of the electrical equipment. Answer. Correct answer, B. Explanation. NFPA 70 PPE selection considers arc flash energy determined by available fault current and clearing time, not just voltage. A affects comfort, not hazard level. C and D don't directly impact PPE selection. Incident energy analysis ensures correct protection level for gloves, shields, and clothing. Question 20. The development of intermittent signal loss between a thermostat and air handler can be linked to wiring conditions. Technician Sam notes no visible damage but finds high resistance on the R-wire path. What is the likely cause? A. Short to ground. B. Partial break or corrosion in conductor. C. Incorrect transformer polarity. D. Opening common wire. Answer. Correct answer, B. Explanation. High resistance without open circuit typically indicates partial break or corrosion, restricting current flow and causing intermittent control issues. A. Would likely blow a fuse. C. Can cause misoperation but not high resistance. D. Causes complete circuit loss. Proper continuity and resistance checks confirm and isolate the faulty section. Question 29. In an effort to improve service reliability, a facility upgrades contactors to heavy-duty models. After installation, technicians note coil overheating during normal operation. Which cause is most likely? A. Incorrect coil voltage rating installed. B. Coil wired in parallel instead of series. C. Magnetic shading ring installed incorrectly. D. Contactor oversized for load. Answer. Correct answer, A. Explanation. Using a coil rated for a low voltage than applied causes overheating. B. Is irrelevant. Coils are not wired in series with other coils in standard use. C. Affects chatter but not heating. D. Oversizing affects contact wear but not coil temperature. Verification of nameplate voltage rating prevents this hazard. Question 30. With respect to a heat pump showing no defrost operation, technician Karen finds coil temperature sensor readings incorrect compared to actual temperature. What should be done first? A. Replace the defrost board immediately. B. Recalibrate the temperature sensor if possible. C. Clean the sensor and ensure proper mounting. D. Check reversing valve operation. Answer. Correct answer, C. Explanation. Dirt or poor mounting can cause false readings, preventing defrost initiation. Cleaning and proper placement restores correct sensing. A is premature without verifying inputs. B applies if sensor type supports calibration, but most are fixed thermistors. D affects heating cooling mode, but not sensor accuracy. OEM guidelines stress verifying sensor condition before board replace.